So here we're given three sets of numbers, and we'll examine the numbers and decide what kind of a distribution each one of these is. So let's look at A. So we have the 5-number summary that's given to us. What's a 5-number summary? The minimum, the Q1, median, Q3, and the maximum. Remember that the Q1, the median, and the Q3 divide the data set into 4 equal parts. The mean is also given. Okay, so let's see what kind of a distribution is it. Is it symmetrical? Is it left skewed, or is it right skewed? With the 5-number summary, that's all you need really to decide whether it is symmetrical, left skewed, or right skewed. If you think of this as a box plot, the median is about 100 and the box is around the 140 and the 65. Okay, and we have the minimum, which is 35, and the maximum, which is 165. I've kind of drawn it to scale, so you can see that the distribution is symmetrical roughly. Another way of determining the type of distribution is by comparing the median with the mean. Notice that the mean and median are roughly the same. If they're roughly the same, you can be sure that it is a roughly symmetrical distribution. Now let's look at B. Again, the 5-number summary is given and also the mean. Just by looking at the mean and the median, just compare the mean and the median. The median is 110. The mean is 80 milligrams per deciliter. So the mean, remember, is not resistant to outliers. The mean gets pulled in the direction of the skew. Okay, since the mean is less than the median, so the mean, which is 80, is less than the median, we can be sure that the distribution is left skewed. There's a skew to the left. The mean got pulled in the direction, the left direction. Okay, so let's just think about what the box plot looks like. Let's say that's a 15. That's 100, 110, 120, and 130. So I've drawn this box plot somewhat to scale, but you get the idea here. Look at this. The difference between Q1 and the minimum is much greater than the difference between Q3 and the maximum. This also indicates a skew to the left. So you could either give this as a reason. The difference between Q1 and the minimum is much larger than the difference between Q3 and the maximum. That's one reason why you could conclude that this is left skewed. Another reason would be to compare the mean and the median. The mean is way less than the median, and that again tells us that the mean got pulled in the direction of the skew, which is to the left. Look at the third example. We have 35, which is the minimum, 65, 100, 140, and then 220. I'm kind of drawing it to scale, slightly exaggerated. Look at the distance or difference between Q1 and the minimum. It's way less than the difference between Q3 and the maximum. This long stem tells us that the skew is to the right. Another way of determining a skew is by comparing the median and the mean. The mean is greater than the median. Remember that the median is resistant to outliers. The mean gets pulled in the direction of the skew. The mean is greater, which means the skew is to the right.